Alright, welcome back. Today we'll be talking about displaying geospatial data, or visualization, which is probably my favorite aspect of GIS. So, the primary output of a GIS is a map. For a GIS to be widely useful, maps must be created to disseminate the data. That's not to say that maps are the only output of a GIS, as statistics, reports, and videos, among others, can be outputs from a GIS. However, maps are the primary means in which spatial information is displayed from a GIS. Let us first define the idea of a map. A map is a graphic representation of a milieu. What that means is a map is a way of representing our world based on the knowledge and culture of the mapping society at a particular time in history. The purpose of a map is to transmit knowledge visually. Maps, uh, Maps are often considered to be one of the three major modes of communication. A cartographer is someone who designs and prepares a map for distribution. Cartographers also study the philosophical and theoretical basis of the rules for making maps. Cartographers are trained professionals in the field of cartography, which is the art, science, and technology of making maps. Cartography is a professional field that has existed for hundreds of years, and it takes cartographers many years of apprenticeship to become skilled at their craft. However, with today's computer technology allowing us to quickly manipulate, analyze, and visualize spatial patterns, map making is now being shared by professions outside of cartography. Therefore, it is important that any user of a GIS be trained in cartography basics so their maps will be effective tools for communication. This module will provide an introductory look at the skills required to perform proper cartographic designs for a map. Alright, so let's talk about kinds of maps. Broadly speaking, there are two kinds of maps: reference maps and thematic maps. The reference map emphasizes the location of objects in the world. It also shows a variety of the world and primarily displays physical objects. A thematic map, on the other hand, emphasizes attributes. Typically, a thematic map will display information pertaining to a single subject or theme, and it will emphasize the spatial patterns and variations of an attribute in that theme. If we drill down into the thematic map kind, there are two kinds of thematic maps: qualitative and quantitative. A qualitative map shows nominal data and focuses on the distribution of that nominal information. It is important to note that since it is a qualitative map, it is not focused on the variation of quantities. Rather, it focuses on the location of the distribution. The quantitative map, on the other hand, shows numerical data, and it focuses on the variation of that numerical information from place to place. It is common practice to generalize numbers on a quantitative thematic map, so that the information being visualized can be displayed potentially hidden patterns, and at appropriate scales. Let's take a look at an example of a qualitative thematic map. This thematic map is a qualitative thematic map showing the standard time zones in the United States of America, taken from the National Atlas. Since a time zone is a nominal type of information, this map focuses on the distribution and location of the time zones, but not any numerical or quantitative information. In other words, it only shows the different kinds of time zones and where they're located. Now let's consider a quantitative thematic map showing a single variable. This quantitative thematic map shows the relative advantage of votes gained by each of the two major party candidates in the 2008 presidential election in the United States of America. The voting information has been collected to county level information for two reasons. One, so the data can be clearly seen at this map scale, and two, so the patterns of distribution of the quantitative voting information can be more easily seen. In addition to the kinds of maps, there are three mediums on which a map may be produced for distribution: tangible, virtual, and mental. A tangible map medium is a concrete object that can be manifested physically and passed from person to person. For maps, the most common tangible medium is paper. Paper has advantages as a medium, such as ease of transport, low cost of production, and no requirement of specialized hardware or software to view. A disadvantage of paper maps are that they are not easily updatable. They cannot show dynamic content, and they are set at a single scale. The virtual map medium is when the map is stored in a computer's memory and visualized on an output device, such as a monitor or tablet screen. The virtual medium has the advantage of being easily updatable, supporting animation, ability to switch between scales, and being able to quickly transport large distances. Disadvantages are that it requires an investment of hardware and software to view, and it may not be as intuitive to use as a tangible map. The third medium is the mental medium of maps. A mental, excuse me, a mental map is a map that is stored inside your mind. This mental map is your conceptualization of reality. Mental maps are not concrete, nor are they stored inside a computer. Therefore, mental maps cannot be transferred between people without first becoming either tangible or virtual. Just think back to when I had you draw your maps of campus. You took a mental map and you made it tangible by putting it to paper. So, in the field of GIS, tangible and virtual maps are the two most common mediums of maps. Now, when you're driving with your significant other to a concert, it might be based off a mental map because someone thinks they're too good to use Google Maps. But hey, that's just life. So, in summary, we can create a tree to show how the concepts of map types, map kinds, and map mediums work together. Starting at the top, a map type is stored as either a mental, tangible, or virtual medium. If the map is stored on a tangible or virtual medium, then this will either be a reference or thematic map. Thematic maps can be further broken down into a qualitative or quantitative map. Quantitative maps can display a single or multiple variable at one time. Alright, so now let's talk about the cartographic process. The cartographic process is a series of steps that we follow to go from an unmapped dataset to a final mapped form. Cartography is both the art, science, and technology of mapmaking. There really is no set process for creating cartographic products. However, there are some best practices that are recommended and a recommended series of steps if you're unfamiliar with designing maps. This section will introduce you to and discuss one recommended series of steps you should follow to design a map. This cartographic process has 5 steps. It is important to note that the steps do not need to happen exactly in this order, as cartography is often a dynamic and iterative process. However, some steps you will naturally want to um, complete first are listed in the recommended order on this slide. The first recommended step is to define the purpose and meaning of the map. The second recommended step is to choose the scale for the map, or extent. Next is to determine the map format, printing limitations, and economics of reproduction of the map product. The fourth step in the cartographic process is to abstract and generalize the data to prepare it for placement on the map. And finally, the fifth step in the cartographic process is to design the map layout. Now let's explore each of the steps in a little bit more detail. So, when we define the purpose and meaning of the map, the goal is to interpret the requirements of the user and to determine what needs to be communicated. Additionally, your job is to determine how to best facilitate communication of your ideas and create a narrative for the map. It is important to note that oftentimes you and or your customer may not fully know these requirements as the beginning. Therefore, expect to revisit and redefine the purpose of meeting as you work the data. and create your prototype maps. The second step of the cartographic process is to choose the map scale. Defined, the map scale is the ratio to the map distance to the Earth distance. The map scale operates along a continuum from a large to a small scale. Broadly speaking, there are three typical scales. A large-scale map covers a small geographic area, and it runs from a map scale of 1 to 0, to 1 to 600,000. A medium map runs from 600,001 to 1 to 2 million. And a small scale map covers a large geographic area, and it runs from 1 to 2 million and 1 to essentially infinity. The large scale maps, since they show such a small portion of the Earth, will allow you to show more details and more features about the Earth's surface. As you move to medium and small scale maps, you are showing a larger portion of the Earth at one time, which does not allow for the same amount of detail. Therefore, medium and small scale maps will not have nearly as much detail as a large scale map. Therefore, the amount of detail you could show in a map is directly dependent upon scale. The selection of map scale is possibly the most important decision a cartographer makes. For instance, if you choose too large of a scale, the map may be so large that you will need to split it into multiple maps. On the other hand, if you choose too small of the scale, you may not be able to show the amount of detail that you wish to show, as the map will be zoomed out way too far. The third step in the cartographic process is to determine formatting, printing, and economics of reproduction. At this point, we should be asking ourselves, what kind of map should we be making? How will the map be displayed? And on which medium will the map be produced? And finally, how much will it cost to create the map on the chosen medium? Depending on your answer to these questions, you may find that while you would like to print the map on paper, the map is so large that it would be too expensive to economically reproduce. The abstract and generalized step of the cartographic process is where you may spend the majority of your time when designing a map. The goal of this step is to prepare your geospatial data in a way that only information that is potentially meaningful to the context of the map is being included. This means they will need to select and organize your geospatial data in a way that is necessary to communicate the concept of a map reader without including unnecessary information or details. The end result is the reduction of the amount of detail in a map to create a simple but effective visual image. There are several methods to abstract and generalize your geospatial data. Selection, classification, simplification, and symbolization are a few of those. First method, selection, is where you only use a subset of geospatial data on the final map product. The selected data should contain the information that is relevant to the message of the map at the chosen scale. The second method of abstraction is classification. Classification is the process of combining observations into bins or classes. The goal of classification is to reduce the number of unique symbols on a map and to aggregate information to a useful enumeration unit, such as state or county. The third method of generalization is simplification. Depending on which scale you choose for your map, you may need to simplify the data so that it is more visually pleasing on the map. For example, on the figure on the screen, the blue line is the original, very detailed path of a river. This data set was probably originally intended to be used on a large-scale map. However, we wish to use this river path on a medium-scale map, but when we place the river path on the medium-scale map, it's so detailed that the river looks cramped, and we are unable to print the fine detail on a piece of paper. Therefore, we simplify the line by reducing its complexity, but still maintaining the character of that river path. This is shown as the red line on the figure. Once the river path has been simplified by reducing the number of vertices, the river now looks good at the chosen scale and is able to be printed with our printing technology. The fourth method of abstraction and generalization is symbolization. Symbolization is the process of assigning such visual variables as color, shape, size, and orientation, among others. The goal of symbolization is to assign a visual marker to represent spatial phenomena being mapped. There are no set rules for how you will symbolize your map. However, there are some strongly recommended conventions that you should consider following. For instance, water should almost always be blue, and land should almost always never be blue. Also, if there is a very common symbol for a feature, for instance, a blue circle with a white eye inside it stands for information, therefore, you should use that symbol on your map when you want the map reader to know that the feature is where they can get information. One of the greater things about cartography is that you could experiment with your design. However, be sure to keep in mind that you need to clarify and consistently communicate your ideas to the map users. Thinking about that when applying it to your labs going forward, since you'll be doing actual layouts, feel free to experiment. If you're not sure that the decision you're making is the right one, just include it in the comments when you submit your map, because at the end of the day, I am your map user for this course. So as long as you can effectively explain to me what it is you're trying to do and why you chose the things you did, you don't have to worry about it being necessarily the wrong choice because I'll be able to see what you were thinking and then provide you great feedback. Hopefully great. So the fifth step in the cartographic process is to design the map layout. Ooh, excuse me. There's much more that goes on a map than simply the data, and we must carefully consider the placement and design of each of these elements. There are 12 elements that compose a map. The first element is the map body, and it contains the geographic information that is the focus of the message of the map, and it should typically be the largest element on a map. The neat line is like a frame for the map. It typically surrounds the entire map and allows the map to separate itself from the surrounding page or elements. The lines can also surround other map elements to set them apart. An inset map is a smaller map body that shows greater detail for an area on the main map body. A scale bar communicates the ratio at which the Earth's been reduced to be placed on the map. The legend is a map element that lets the users know what each symbol on the map means. The title, typically at the top of the map, is usually the largest text on the map and provides a short descriptive statement about the purpose of the map, and it may include other pertinent information, such as the time frame for which the map applies. The directional indicator, more commonly known as the north arrow, lets the user orient the maps relative to a direction. The metadata is the documentation for the map and the data displayed on the map. Metadata should include items such as the date the map was created, the author of the map, and data sources for the map data as shown on the map body. Ancillary text and ancillary objects are elements included in the map layout to support the map's message. These may include images of locations or features displayed, locations of the map, charts, graphs, sounds, videos, or simply explanatory text. The graticule references a coordinate or measurement system that the map users can use to derive the location coordinates. Last, labels identify features on the map, typically based on information stored in the features attribute table. Another thing to consider when designing the layout is the scale, size, and shape of the primary object being mapped, and the medium onto which the map will be produced. For instance, if we are mapping Tennessee, we notice that the shape of Tennessee is roughly a wide but not so tall parallelogram. Therefore, we may choose to orient the map media in a landscape setting so that Tennessee can use the maximum amount of media as possible. Additionally, we may be constrained by the size and shape of the media. Therefore, if we have been asked to produce a map showing all manhole covers in a city such as Houston, but we are constrained to a paper size of 8.5 by 11 inches, then we know that we must split our map up into potentially hundreds of pages, each showing a small portion of Houston, as we would be unable to show enough detail to show every single manhole cover on a single 8.5 by 11 inch piece of paper. Alright, so now let's talk a little bit about map design and map elements. So, the title of a map should be dominant in size and is typically the largest text on the map. A good map title should focus the user's attention on the purpose of the map. A good map title should also be brief but descriptive. Typically, a map title will include information such as where the map is focused, what information is being focused upon, and the time frame for which the map is applicable. Map titles are typically placed at the top center of the production medium. However, a map title can truly be placed anywhere, so long as it is easily found by the map user. If the map is a figure in a larger document, you should not place the title on the map, but instead place the title of the map in the figure caption. The map body is the main focus on the map, and it contains the geographic features that are important to the message of the map. The map body is typically the largest element on the map, and it should dominate the user's attention. Typically, when designing a layout, the map body is placed first, and other elements are then placed around it. However, do not be afraid to move or resize the map body to better accommodate other elements that you find necessary. In the end, however, the map body, being the map element we want the users to focus on the most, should be easy to find, dominant, and of adequate size to show the geospatial data. Inset maps, or small ancillary maps that have a larger scale than the main map body. The role of an inset map is to show more detail in a map body of a smaller geographic area. On this illustration, the United States of America is the main map body, and the smaller map of Arkansas in the lower right-hand corner is the inset map, which is showing a smaller area in more detail. To make it obvious to the map reader where the inset map is referring to on the main map, you should show an outline of the extents of the inset map on the main map body, or provide leader lines from the main map body to the inset map. A location map is a small ancillary map that is at a smaller scale than the map body. The location map identifies a location of where the main map body is in a larger geographic context. A location map is to be used when the location of an area on the main map body is unfamiliar or not intuitive to a map reader. In this illustration, the map of Arkansas is the main map body, and the smaller map of the lower right-hand corner is the location map. Similar to the inset map, there is a visual marker on the inset map that shows the map reader where the main map body is located. The map scale is used to measure linear relationships on the map. Map scale is typically included on a reference map, but is not required to be included on thematic maps. A map scale should only be included on a map when you want the user to measure the distance on the map, or the scale of the map is not intuitive to the map reader. There are three types of scales that we could place on a map: a graphic scale, a verbal scale, and a representative fraction scale. The graphic scale is perhaps the most common type of scale placed on maps. The graphic scale is a visual representation of the ratio at which the Earth has been reduced. The graphic scale typically starts at 0, and it measures out to a meaningful, typically round number. One major advantage of a graphic scale is that if the map is enlarged or reduced, say using a photocopier, then the graphic scale will scale with the enlargement or reduction and will always be correct. This is not the case with the verbal scale or the representative fraction scale. The second type of scale is the verbal scale. The verbal scale is a statement that describes how a distance measured on the map relates to a distance measured on the ground. Again, it is important to use meaningful, typically round measurement units to make it easier for the map user to measure distances. Third type of scale, excuse me, the third type of scale is the representative fraction scale, sometimes referred to as the unit scale or a ratio scale. In the representative fraction scale, the numbers to the left of the column represent how many units of measure of a map there are related to the number on the right side of the column. The legend map element identifies unknown or unique map features succinctly. A legend may optionally have a title or contain the title of the entire map. The legend needs to have representative symbols that are found on the map, followed by a description of what the symbol represents. The symbols on the legend should be the exact same color, shape, and size of the symbol shown on the map. If the symbol on the map varies in size, the symbol in the legend should be the size of an average size symbol on the map. Let's look at two examples of legends. For a general reference map, it would display all symbols found on the map. The representative symbols should be to the left of the short description, and the legend can be organized vertically in one or more columns. For thematic maps, and in this case, a graduated symbol map, the graduate circle legend is to show how the size of the symbol changes, with the value of the attribute that is being represented. Graduated symbol legends can be placed in a vertical layout, horizontal layout, or a nested layout. The directional indicator is often considered as part of a legend, and it may be placed inside the neat line uh, near the legend or elsewhere on the map. So the directional indicator, commonly known as the north arrow, is necessary when north is not at the top of the map, or the map readers are unfamiliar with the area being displayed on the map. Because map readers are typically familiar with orientations of large landmasses or their own country or state, north arrows are often not necessary on a small scale map. The directional indicator should be reasonable in size, not dominant at all, but it should still be easily found by the map reader. Labels communicate attribute or ancillary information directly on the map body and related to map features on the map body. The purpose of the label is to identify features on the map and help users to orient themselves to the information being displayed on the map. Labels should be placed at locations that follow the map reader to easily associate the label with the feature it is labeling, and it should be reasonable in size. The metadata or credits cite the source of the datasets used to create a map and provides the map author's information, the date the map was created, and other explanatory information about the creation of the map. As the metadata is typically not an important part of the map, it should not be visually dominating. Instead, the metadata is typically placed along the bottom edge of the map and de-emphasized. If the map reader wants to read the metadata, they will typically spend a little time searching for it. The graticule elements visually represents a coordinate system or location scheme. You should include the graticule of a map if the map reader will be referencing coordinate locations throughout the map. You should use meaningful divisions on the graticule so that it is easy for the map reader to use it. Typically, graticules are omitted from thematic maps as the purpose of a thematic map is not to measure, but look at the spatial distribution and patterns of the data. Graticules can also be placed on top of our map features or behind it as a just kind of way to improve the visualization of the map. The neat line is considered the frame of the map. The neat line should encapsulate the data and, if needed, map elements. The goal of the neat line is to provide a nice, clean frame for the map to live within and to separate the map from surrounding items on the medium and direct users' eyes to the center of the map. Neat lines should not be visually dominant, but they should be large enough so that the eye can use it as a frame. Ancillary text and ancillary objects or additional supporting information that provides a greater understanding of the topic of the map Examples of ancillary text or objects may be text, pictures, sounds, movies, graphs, and so on. Two common reasons to include ancillary text on a map are to indicate to the map reader the ways in which the data was manipulated, or that it is pertinent to the interpretation of the map, or to indicate special cases or missing data. When the map elements describe in more detail, we should take a brief moment to explain best practices when placing these map elements on a map. It is important that you place map elements so that they are positioned and sized in accordance with their importance. The most important items should be roughly at the center of the map. Important items should also be placed at the top of the page. This is typically why the title is at the top of the page and the map body is in the center of the page. Map elements should use as much space as possible within the neatline so that white space is reduced. Additionally, the map elements should be placed around the map so that the map has a visual balance that is pleasing to the eye. Alright, so up until this point in your life, you've probably looked at hundreds of maps, but you've probably never critically critiqued one. With the perception of maps, while the perception of maps may be that they are neutral, infallible representations of reality, the truth is that maps are created by cartographers who may make errors in design, or unintentionally or intentionally bias the map. It's very easy to lie with maps. There's a whole book on it. So it is good exercise to look at a map and to critically think about it, and then critique the map. So in this short section, we will critique a map and then discuss its redesign. This is a map that may be considered typical for someone who is new at making maps. There are some undesirable characteristics of the map. The author chose not to change the default behavior of the mapping software, which is the probable cause of some of the issues with the map that probably simply occurred due to the map author not knowing any better. In either case, let's look at the map and point out where the map design could have improved. As the title is often the first thing a map user reads, it provides a conscious description of the map. Let's examine that first. The current title of the map is simply entitled Population Density. While at its core, this map is about population density, the title is still fairly vague. It doesn't answer the question of when the population was that dense and why we are only seeing the lower 48 states of the United States, or why Alaska and Hawaii were left off the map, minus that little tidbit of Alaska poking there and Puerto Rico. Additionally, the title is slightly off center. It would be much better if the title was centered on the top of the page. Now let's focus on the north arrow. The north arrow is way too large for this map. Remember that items should be sized relative to their importance. North arrow is not so important for this map that it would need to stand out that much. Additionally, assuming that the audience for this map would be Americans, the north arrow might not even be necessary since Americans are hopefully used to seeing the United States and having north be on top of the map, making the north arrow for this one a bit redundant. If the north arrow is to be left on this map, it should be made considerably smaller and placed out of the way. If we look right below the north arrow, we have the metadata showing the map author and the data source. There are two problems here. One, the text is too large. The map readers will look for the metadata if they want to see it, but it should not jump out this much. The font size should be reduced for the metadata. For the data source, Esri is not very descriptive. It doesn't tell us what year the data was created, and a majority of map users would not be able to track down the original data source simply by Esri. Next, let's consider the scale bars. The scale bars have multiple problems. The first one of the scale bars represents the distance in decimal degrees. A decimal degree is not a useful unit of measured distance on a map, and I cannot think of the last time I've ever measured using decimal degrees. Second, the divisions of each of the Second, the divisions and endpoints of the scale bars are not meaningful, easy to use numbers. Instead of 0 to 32, why not 0 to 30? And instead of 0 to 2,840, why not 0 to 3,000? Using round numbers on your scale bar makes it easy for the map reader to scale distances. Third, the scale bars are too wide. The scale bars could easily be 1/3 their width and be just as useful, and not so visually dominant on the map. Remember, the scale bars in this map are not that important, and they should be de-emphasized so as to not attract the eye from the map body. Lastly, the scale bars are too tall. This causes them to be emphasized, distracting from the map. Next, let's focus on the legend. As a matter of style, you should not title the legend with the word legend. Map readers know that this is the legend, and you could use that space better by replacing it with a descriptive title for the legend. One exception would be for, say, elementary school children who are not familiar with the components of a map yet, and therefore need this instruction about what a legend is and what it looks like. Next, the description of the population density data is not well formed, and it provides the column name from the attribute table, which is not useful to the map reader. Instead of the word counties and pop07 underscore square miles, a more appropriate legend title would be persons per square mile. Looking at the numbers to the right of each patch in the legend, it is not consistent with the map number of decimal places. For instance, the bottom entry has no decimal places and is simply the entry 0 to 10, while the next three entries above it have two decimal places for the lower numbers and no decimal places for the higher number, while the top entry has two decimal places for the lower number and one decimal place for the higher number. Like we said before, be consistent. And since we're talking about persons, we should round to the nearest whole number because, well, we're not going to have 0.01 of a person. The bottom two entries, referring to the background of Canada and Mexico and the ocean background, are not required for this legend, as the water and surrounding county features aren't unfamiliar to the map reader, and therefore they do not need to be placed on the legend. Additionally, the symbol for the ocean background on the legend blends in with the actual ocean background behind it, therefore making it look like there is no legend entry for the ocean background. Now, let's focus on the map itself. The United States is slightly off-center, and it could be made quite a bit larger to fill the page. There's quite a bit of white space above and below the main feature of the map, which is considered wasteful. Additionally, only the southern tail of Alaska is shown on the map, which looks sloppy, and it makes the map reader wonder why only a portion of Alaska was shown. By enlarging the contiguous United States, the tail of Alaska would not be shown here, or Puerto Rico. If we consider the features included on the map, we have county outlines, roads, and rivers. The question becomes, are roads and rivers really necessary to show a map of population density? Perhaps the roads and/or rivers should be left off the map so that it is less cluttered and simpler to read. Additionally, the color of the roads is very close to the color of the most densely populated area. This makes it hard to see exactly what is going on in the counties underneath the roads. The smaller counties may be completely covered by road lines, making it look like a county is densely populated when it is not. Moving to the map projection, it's clear that this map is not any particular projection based on the flatness of the northern boundary line of the United States. As the data that we are showing is based off of population per square mile, an equal area projection should be applied to this map, as relative size is important when determining how dense counties are. Another thing to note about the map is that although Canada and Mexico are included, South America is not. If you're going to include surrounding counties, you need to include all of the surrounding countries that may show up on the map. Lastly, there's no neat line surrounding the map. In order to provide a nice frame for the map and to have it stand out against its surroundings, a neat line should have been included. Here's the same map with all the issues highlighted. As you can see, what may initially look like an okay map really has many, many problems. If you submit something like this, it just might have an aneurysm, and you'll get a bad grade. So this is a redesign of the map. The redesign took about 5 minutes of time and made the map significantly more attractive and useful. Note that the title is much more descriptive. It states that it is the population density for the year 2007, and specifically notes that it is for the contiguous United States of America, which lets the map reader know that Alaska and Hawaii are purposely excluded for the map. The projection is changed to an equal area projection that allows for the map reader to make proper aerial comparisons between counties. The roads also have been taken off the map, which allows for the counties to be the main focus of the map and not be obscured. The scale bars have been greatly reduced in size, are using round numbers and meaningful units. The north arrow has been greatly reduced in size and placed in a better location. The metadata is more descriptive and is a good size. The legend has been reduced in size and has been given a descriptive title, and the numbers are now consistent with respect to the number of decimal places. Lastly, a nice frame was placed around the map. Even with this redesign, one could argue there are still a few issues. For instance, the metadata is placed on top of some of the background data, which makes it difficult to read. Additionally, the scale bars are half on and half off of Mexico, and rivers are still included on the map, which might be a feature that is not required. However, overall, with just a little bit of extra work and careful consideration, we've gone from a very poorly designed map that was hard to read and not pleasing to the eye, to a well-designed map that is much easier to read and is pleasing to the eye. Remember, map design is an iterative process. Don't be afraid to radically redesign your map a few times to see how you might improve it. Also, show your map to a friend, family member, or a colleague and get their feedback. Even though they may not be trained in cartography, people can often easily identify an ugly map, and it might provide an important perspective on your map design. Alright, so this last section focuses briefly on ethics and cartography. The Cartographer's Code of Ethics will be discussed, which is from the Book of Cartography Thematic Design, the 6th edition by Dent, Torgerson, and Hodler. Those of you that will be taking visualization, you'll be using this book later. So, there are 10 items in the Cartographer's Code of Ethics. The first item is to have a straightforward agenda. The purpose of your map should be readily evident to your map reader, and it should not be deceiving or confusing. Maps should be as transparent as possible with regard to the purpose of their message. The second code is to strive to know your audience, to effectively communicate your message using a map. You need to be aware of your audience and what their level of knowledge is with respect to your message. For instance, if you are creating a map that will show breeding grounds of a very specific type of fish, and you use scientific names and terms to label the map, but your audience is at elementary school children, your map and therefore message will be lost. Conversely, if your audience is going to be a very scientifically minded group, and you should use the complicated terminology and include more depth to the map, knowing that the audience will be spending more time dissecting your map and looking for deeper patterns in meaning. Designing a map with the wrong audience in mind can render your map almost completely useless. The third code is not to intentionally lie with data. Do not mold the data with the intent to deceive. You should strive to have your map to be as neutral as possible when displaying the data. Like books, people tend to trust maps for being trustworthy. The fourth code is a map should always show all relevant data when possible. Showing relevant data provides important context for the map reader to use to interpret the message of the map. Excluding important information or contextual information on the map may paint a may paint in a complete picture of the situation and not allow your map reader to get the whole story. This is not to say that you should include as much data as possible, as cluttering the map with unimportant information is almost as bad as leaving out important information. You should use the minimum amount of information possible to convey your intended message, which will create a clean, conscious map. The next code is a map should not discard contrary data just because it is contrary. Again, your map should be as much as possible a neutral representation of reality. Just because the data does not fit the message that you had in mind, you shouldn't just discard it. The sixth code is that the map should strive for an accurate portrayal of the data. Do not intentionally place the data in a poor light or exaggerate or diminish the data. The seventh code is to avoid plagiarizing. Just like we write a scientific paper, you should always properly cite your sources of information. This is also true for maps. Properly cite your sources in the metadata on the map. The eighth code is to select symbols that will not bias the map. The symbols should be neutral representations of features. If you choose a symbol that would cause the map reader to unfairly view the feature in an unfavorable light, then you are purposely biasing the view the feature and viewing the feature in an unfavorable light. Then you are purposely biasing the map and not providing a neutral representation. Code number 9 in the cartographer's code of ethics is that a map should be repeatable. What this means is that if you choose the symbols well, had a straightforward agenda, did not lie or discard contrary data, then another cartographer should be able to independently create a similar map using the same data and focusing on the same message. By similar, I do not mean the same colors, layout, or symbols. I mean a map that successfully portrays the same message. The final code is to pay attention to different cultural values and principles when making your map. If possible, you should be sensitive to cultural values and principles of your audience. For instance, certain colors represent different meanings in different cultures. While red may represent danger to an American, it may represent peace in another culture. If you're making a map for an audience whose culture differs from your own, you should do some research on topics relevant to map making, such as significance of color or significance of certain symbols in that culture. In summary, when creating a map, you should always strive to provide a truthful, neutral representation of reality targeted specifically for your audience's level of knowledge, so that your map can effectively convey your intended message. All right, as always, if you have questions on this lecture, feel free to ask me in class, shoot me an email, or post them in the comments of this YouTube video. If you post them on YouTube, I'll do my best to check and see if there are any new questions and answer them to the best of my ability. All right, thank you all and have a great day.